foreign languages, I would like to thank you for coming. So we are here today to listen to the presentation of first-year students who have recently been on 2 excursions to Sukhoi Aircraft Company and to Central Area Hydrodynamics Institute, or Cyberforschung. So, and let's not waste time and give the floor to the first group, group number 261, and it's presented by Professional Policy.
So, shall we start? Okay. Good morning, everyone. My name is Kharashilov Alexey, and I'll be presenter. First of all, I'd like to thank esteemed guests and promise that our presentation won't be long, but we'll try to make it interesting for you. Now it's time to introduce our team. We are students of Moscow Institute of Physics and Technology, the Department of Aeromechanics and Flight Engineering, from group number 261. Our presentation is devoted to the legend of the world aviation industry, to the legend of the world aviation industry, Sukhoi company. Hope you'll enjoy it. Firstly, Egorov Andrei, in a few words, will tell you history of Sukhoi company. By the way, any questions are welcome after presentation.
Sukhoi was originally conceived not as a separate design bureau, but as a project to create Buran Orbiter, which was a similar American project, Space Shuttle. In the early 1920s, under the supervision of Anton Nikolaevich Tupolev, Tsagi set up a department of aviation, civil aviation, and aircraft prototype engineering, also well known as Agos. In October 1930, Sukhoi becomes a head of Agos team, which is a process of designing and building various aircraft to an own. Formed the backbone of the design team of Pavel Sukhoi, later called after him. So, design team was formed. It was headed by another famous engineers, Ivanov, Simonov, and since 1999, the chief executive officer has been Pogosyan. During its existence, Sukhoi has made a lot of different plans, civil and military. Some models were improved and are still in use. Practically all Sukhoi creations are well known all over the world. I think there is no person who has never heard about Su-70 or Su-27. The legendary platform which became a base for Su-27CK, one of the best patterns in its class. Su-27 UPK, which was designed for teach airborne person pilot skills. Supersonic fighter C-1 and T-3, the first Soviet all-weather strike aircraft, armored Su-25 with variable sweep wing. Armored Su-25 attack aircraft designed for destruction of battlefield targets, also creation of Sukhoi engineers. But besides, the company is notable not only for military aviation. Sukhoi civil aircraft is currently engaged in the family of regional aircraft Sukhoi Superjet 100.
Thank you, Andrei. It was very interesting, but our time is running out, so I asked Tikov Maxim to inform us about Sukhoi company nowadays. Maxim, please.
Today Sukhoi is well known all over the world, like the major Russian aircraft company, employing over 26,000 of people. Today Sukhoi supports a full cycle of work in aircraft engineering, from front-end engineering to comprehensive after-sales super. On the one hand, Sukhoi provides our country with Su-combat aircrafts, strong high-tech weapon systems which can guarantee our freedom and clean sky. Sukhoi is the major manufacturer of export aircrafts placed third in the world by the number of produced modern fighters. But on the other hand, Sukhoi is famous not only for military aircraft. Sukhoi is one of the biggest leaders in civil aircraft development and producing in our country. So nowadays, Sukhoi is trying to become firstly high performance, fast growing company with a team of high tech professionals. Secondly, to be a think tank of Russian aviation industry, and the last to be a model of stability and cooperate business system standards in line with interests of Russian Federation.
Wow, it was exciting. Thank you, Maxim. As you know, we had an excursion recently where we were shown a new plane. And now Sveta wants to share her impressions. Sveta, please.
Sukhoi Superjet is a new aircraft family allowing its passengers to experience the main line level of comfort. The leading-edge technologies are used in every stage, from design and development to final assembly, delivering a modern, economically efficient and a globally marketable aircraft. Without preliminaries, it can be said that this plane is superb from its bottom to the end. Optimal piloting in automated mode, together with the fail-safe flight control system, ensure additional fuel efficiency and improve flight safety. Furthermore, Sukhoi Superjet 100 features fully electronic fly-by-wire control system for piloting, landing, GIF extension and retraction, and a brake system to prove its high maintainability and brake perfection. It is also equipped with built-in failure detection system, which is able to find any failure. Each aircraft is also powered by the new engine, which is developed by PowerJet to meet the highest performance and eco requirements. A strong focus was also put on engine maintainability. The creators of Sukhoi Superjet 100 did a huge work to do such a thing. Airframe parts are manufactured at Sukhoi facilities located in Komsomolsk and Novosibirsk, while the technologically advanced production site in Voronezh provides them with aircraft parts made of composite materials. Branch in Komsomolsk is responsible not only to make some details of the plane, but also for final assembly, flight tests, aircraft acceptance, and delivery-centric operation. All in all, Sukhoi Superjet 100 is a perspective project. That's why it is really interesting, not only for Russian airlines, but for international airlines.
Thank you, Sveta. In addition, the tour was great, and we want to thank the people who made it possible. And now, Kislovsky Artyom will talk about the importance of Sukhoi Superjet.
As it has already been said, Sukhoi Superjet is a really perspective project, so that's why it is popular among different airlines, including international ones. The plane can be adopted for different requirements if the change don't bring any harm to efficiency and safety. This feature makes it more attractive. Sukhoi Superjet 100 has got the validating letter, type certificate, from Aviation Authority of Mexico. Signed contracts with Transaero Airlines, Air Company Yakutia, and Lao Central Airlines. Thank you.
It was Kislovsky Artyom with his report about Sukhoi Superjet 100. Finally, our presentation is coming to the end. As I promised, it was not long and hope interesting. And now, thank you for your attention. Questions, please.
I want to direct my question to Sveta or Kislovsky Artyom, who have told us about Sukhoi Superjet. So my question concerns this. This airplane has been designed by Sukhoi in cooperation with another aircraft company. Do you know the name of this company?
Света.
Очень the name of this company. So actually, it was
Trying to say that this
it's
is
a
a
Russian company. Yes. So, and when was its maiden flight conducted? Do you know the date? And maybe the route?
It was made in 2012. Exactly.
Sorry?
It was made in the year 2012, but
In 2008.
8, right. So, and the route was from Yerevan to Moscow. So, and one more question from me. So, what is the main advantage to your mind of Superjet over its main competitors?
The most important competitors for Superjet 100, Boeing and Airbus.
And what advantages does it have over them?
About Boeing and Airbus.
Yes.
It's efficiency.
they try to make this plane as efficient as possible. So that's why they made an engine powered by our jet.
Okay, so and have I give you a hint? What about the price of the jet?
For the price.
Of the Superjet. So this is one of the main advantages.
We are not so rich to
$38 million.
Yes, 35 approximately. Yes, million dollars. Okay, thank you.
Some questions? Anybody?
Next question. Maybe to you or Elena Viktorovna. Why do you have only one slide to one person?
This is the requirement.
Requirements. Yes? That's
We try to make our presentation not long.
The students have only 10 minutes
10 minutes.
for the presentation.
They are restricted in time, strictly restricted. 10 minutes, not more.
It may be 10 slides. You have five slides.
Well, we'll do this presentation first, for the first time, so don't know about
Understand.
such moments.
We'll try to do more next.
So no more questions. Thank you for your presentation. It was rather good.
Shall we start? Good morning, everyone. Thank you for coming here this morning. We are students of Moscow Institute for Physics and Technologies from 260. We are students of Moscow Institute of Physics and Technologies. It's a faculty of aeromechanics and of flying engineer from 261st group. My name is Salenov Alexey, and I will be your host today. We are going to tell you about TSAGI. Our presentation consists of 4 parts. The first one is about the history of TSAGI. The second one is about the main activities of the institute. The next speaker will tell us about window tunnels, and the final part of our presentation is applied dynamics and aircraft control systems. Let us begin. I would like to get the floor to Diana, who will tell us about the history of TSAGI.
Good morning. TSAGI, which also known as the Central Aerodynamic Institute, was formed in Moscow in 1918. In the 1920s and 30s, the TAGI project ranged from prototype airplanes to airsleds and from torpedo boats to the wind-generated electricity. Gradually, the direction involved and centered upon aerodynamic research. The institute built its first large tunnel in 1925. In 1935, new department of TAGI relocated to the outskirts of Moscow to what later became the town of Zhukovsky, the air city of the Soviet Union. The first to win the large tunnels were completed in the 1937. By 1939, TAGI became the proud owner the largest wind tunnel in the world. This wind tunnel provided the opportunity to study the behavior of full-scale aircraft. In the following years, TAGI became the founders of leading airspace institutes and design centers, such as the Institute Airspace Materials, the Institute of Aeronautics, Tupolev Bureau, and the Flight Research Institute. During the years, TAGI resources were directed to the military applications. In the 1933, TAGI introduced a new transonic wind tunnel capable of using the variable and the constant density testing agents. TAGI developed a new compositions and components of wind plane stability criteria and strength standards. The post-war period was characterized by research on near and post-sonic speeds. Since the 1950s, TAGI has been involved in all areas of fundamental aerodynamic research in aerodynamic, flight dynamic, flight stability and strength. However, it's important to remember that it's not the machine what are the strange, it's the people. TAGI always had a magnificent scientist in their ranks, and I hope that someday students of MIPT will join them. Thank you.
Thank you, Diana. And now let's move on to the second part of our presentation. And that is Andrew, who would like to tell us about the main activities of TAGI. Welcome.
Good morning, ladies and gentlemen. As Dasha said, I'm going to tell you about the main activities of TAGI. The research and experiments in many different fields are done there, but I would like to mention only several main activities. They are aerodynamics of airplanes, helicopters, missiles, other aircraft and their engines, flight dynamics and aircraft control systems, improving the safety of flight and improving the pilot information, development of flight stands for testing various aspects of the flight, air elasticity of aircraft, industrial machinery and building structures, computer technologies in designing and manufacturing aerodynamic models, designing of experimental facilities for ground tests of aviation, rocket and space technologies, gas dynamics and hydrodynamics. In addition, TAGI do research of alternative energy sources for planes and helicopters and research in plasma physics and nanotechnology. Moreover, the Institute develops concepts of perspective aircraft, new aerodynamical configurations for planes and helicopters, the new construction schemes, the aircraft stability and controllability criteria, strength standards, and the theory of flight time. Also, they perform theoretic and experimental research of aviation, rocket, and space technologies. It is ensured by the unique experimental facilities which can model the flight of aircraft at speeds from 10 meters per second up to 25 Mach. We can find a lot of outstanding examples of Tsagi activity. I would like to name some of them. They are, for instance, circummaneuverable fighters based on Su-27 and MiG-29, the most high-rise interceptor in the world, the MiG-25, aerospace plane Buran, and finally, the largest plane in the world, An-225 Mriya. This list can be completed by dozens of aircraft, ships, and buildings. So if you want to find out more, don't hesitate to ask questions. Thank you for your attention.
That was very interesting, thanks. Certainly, everybody know about the Tsagi wind tunnels, which are very famous. Zhenya will tell us more about them. Please greet him.
Good afternoon, ladies and gentlemen. I would like to introduce a speech on wind tunnels for today. First of all, what is a wind tunnel? A wind tunnel is a tool used in aerodynamic research to study the effects of air moving past solid object. A wind tunnel consists of a closed tubular passage with the object under test mounted in the middle and a powerful fan system that moves air past the objects. A complex Tsagi consists of more than 60 gas dynamic systems and wind tunnels. They provide a simulation of the flight conditions at the speeds of 10 meters per second to 25 Mach numbers. The first object visited was wind tunnel T101. T101 is a subsonic wind tunnel with 2 reverse channels and an open test section. 2 fans of total power 30 megawatts generate the flow. Computerized measurement and control complex enables data registration and processing. And during 70 years, scaled models of aircraft and helicopters, many types of aerospace vehicles, and different industrial objects have been tested in T101. And of course, we have to mention the huge size of this tunnel, 24 meters in width and 14 meters in height. Is so powerful, it definitely made a great impression on all of us. And the next object we visited was wind tunnel number T128. It's a continuous running wind tunnel designed for investigation of aircraft models at subsonic, transonic, and supersonic velocities. The technological advantage of this tunnel is adjustable perforation of the test section walls, which allows to work with higher velocities and a wider range of angles of attack. And unlike T101, this tunnel is not so large and the flow is generated by a compressor, not by fans. However, this tunnel can work with high numbers of reynolds. The capabilities of the wind tunnel T128 are widely used for investigating different models of airspace vehicles, rockets, civil and military aircraft of various purposes. In conclusion, I would like to say that it was an impressive trip that unquestionably makes you proud of Russian science. Thank you for your attention.
Wonderful, Zhenya. We are grateful for your speech. And now let's hear about flight dynamics and aircraft control systems. I would like to invite Anastasia with
Hello, dear guests. Today I will have the pleasure to tell you about flight dynamics and aircraft control systems, which have always been an area of high priority for Tsagi. Flight simulators and control system simulators have played a great role in developing a wide range of airplanes and fly-by-wire systems. For instance, this engineering multifunctional simulator you can see on the video fully creates flight conditions. You can even hear the engines roar and the wheels hit the ground. Everything is extra realistic. More than that, you can... Could you please turn the sound off? Thank you. You can change all the conditions from the airplane and type of engines to the handles, displays, and control system. This can be accomplished by changing the mathematical model and the software. So it is a universal instrument for solving a certain class of engineering problems, such as, for example, creating the best conditions for the pilot. Furthermore, it is now used to test a new intellectual system that will prevent air crashes, no matter what the pilot does wrong, by hindering dangerous angles of attack, roll, and speed. Another noticeable machine is the Aerobatics 1010M. Its spherical imaging system always has a great impression on the viewers. It can generate all kinds of group fights, extra maneuverability mode, and even the impact of overload on the sight of the pilot. I myself got a chance to try it out, and I was truly impressed. I had the complete feeling of the presence, and it was indeed an unforgettable experience. All in all, the project is admittedly exciting, and it is definitely fascinating to have a job that is connected with that. Thank you.
Thank you, Anastasia. That really was catching. To sum it up, I would like to say that SAGI has always been of great importance and necessity for the country, and it will be great if a lot of smart, interesting young people would work there. Also, on behalf of every participant of our group, I would like to thank you for your attention, and if you have any question, we are eager to answer them. Thank you.
I would like to ask a question to the person who told us about wind tunnels.
Yes.
Do you know anything about the cost of the experiments and the mass of the air throughput in the wind tunnels?
Oh, no, I don't work in SAGI and I don't know such
I
information.
can say some words. For example, 109 wind tunnel. This wind tunnel is located under the ground. Do you know about this wind tunnel? The throughput of the air at the Mach number 1 is about 1 ton of the air per second. And the cost about 1,000 ruble per second. So you can calculate the cost of the experiment if you need to obtain the total polar curve. It takes about 20 seconds. The cost will be 20,000 rubles. It's for the future. It's not question, it's explanation. I understand that you don't know that.
I would like to have such a tunnel in my home. Thank you.
So I have a question as well. So my question to Master Shevchenko, who has told us that we were able to try flight simulator. So, and I saw your eyes and I remember how excited you were. So, and didn't you screen on your mind that you would like to change your major and start managing planes rather than construct them?
Yes, I had such thoughts, especially when we went to Sukhoi Suproject, to another excursion. We got to sit in the pilot's chair too, and it was really exciting. And I've been flying a lot since my early childhood, and I always loved the way pilots talk to us, and in my mind they are all really great people with great personalities. So I think that pilots are really interesting people.
So, and what about the organization of excursions? Do you have any comments from the students' point of view? Would you like to change anything, to add something to this excursion?
Yeah, I think that for the excursion in SAGI, they could divide us into smaller groups, because in many places we didn't have a chance to hear everything and see everything. So if we had smaller groups, then we could pay more attention on what the presenter tells us.
So in Transneuropa you had schoolboys or school girls beside you who all the time were hindering and interrupted you? Yes.
Yes, that
Makes a mess.
yes, but what we saw and what we heard, what we found out, everything was awesome. I felt so interested, and it makes me so proud of the faculty I'm studying in.
May I ask about flight simulators? Do you know that we have at our department flight simulators too?
Yes, I know. I've been on the open day. I've walked children through our institute, and they saw it. It was interesting, and we let the school children to sit there and try to touch them too. And I can say that they were interested, and I hope they will come to our faculty too.
And do you know the problem we study on our flight simulator?
No, I don't.
I give small explanation. We study the air refueling. It's very difficult maneuver. Aircraft landing on the air carrier and aircraft landing on the mountain airport. So we study influence of water structure and turbulent atmosphere on the aircraft in its maneuver. I invite you to our flight simulation.
Thank you. And there's also a helicopter flight simulator in our institute too.
There are no questions, and thank you. Book was very well done.
Really good. I ask the last question. Where do you have the source of your presentation, picture and movie?
It was from the official site of Tsagi.
Okay.
And all the videos were posted there.
Video
From Tsagi.
Ah, okay.
Official site.
Okay, official site.
Thank you for your presentation.
So, and the next group to introduce presentation is group number 253 and represents the government.
Just some seconds, we will. Well, I think we are ready to start. Hello to everybody. Good morning, dear ladies and gentlemen. We are really glad to see you all here this morning. And today, let me introduce our group. We are group number 263 from Department of Aerodynamics and Flight Engineering from Moscow Institute of Physics and Technology. Today we would like you to tell about our excursion to Sukhoi Civil Aircraft Company, which happened just several weeks ago, but still we are under emotions, and that's why I would like to share our emotions with you. But of course not only emotions and brilliant information that we get. And so, our excursion began in the checkpoint of the company, and that's why Maria Chikunova will tell you some facts about the company, about its history. Maria, you're welcome.
So, nowadays, Sukhoi Superjet 100 is widely discussed in the society. Some people speak of it negatively, others positively. So, where is the truth? Let's make a little investigation. After the USSR collapse, most major aviation plants and companies turned out to be in Russia. So, aviation manufacturing was announced to be a government priority. Despite this, it began to decline. So, for example, on this chart, we can see that the level of passenger is growing from 1980 to 1990. But then we see a significant fall, and then the level stabilizes because of the overseas flights. On the second chart, we can see that in 1992 there was the top of the chart, so that 81 aircrafts were made, and then the level falls to the 5 aircrafts in 1996. So in 20
2002, a Russian aerospace agency announced a competition for a creation of a new regional aircraft. As you can guess, Sukhoi won it, and so from that time the active work started. Nowadays, aircrafts are assembled at the aviation plant in Komsomolsk-na-Amur. Then they are sent to Ulyanovsk, where they are painted. After this, they spend some time at Zhukovsky airfield, and after that, they go to their new homes. So now we will show you a short video about this process.
Левое дело.
So now let's return to our presentation. Now I would like to tell you about a little about my father. So he works in the company practically from its foundation. It was a very exciting process for me to follow the project from its birth. So for the first time I saw its simulator in 2007, but a real aircraft was only in a far dream. But in 2 years we were happy to see a real aircraft in the sky. Its first flight at Zhukovsky Air Show was followed by 4 flights. Last year a big catastrophe happened in Indonesia. It was a big strike for the families. The crew consisted of real aces. Hope that they are rest in peace. It was very hard, but now life continues and the work is underway. So,
thank you a lot. We really were impressed with this video because it shows the plane from its really birth to its more old years, if we can compare it with a person. But now let's come back to our excursion, and the next part of our presentation we decided to divide between people who are interested in that or this part most of all. And that's why now Maria Ovsyannikova, you're welcome. She will tell us more about technical characteristics of Superjet.
We went to the hangar where we saw 7 airplanes. All of them were painted according to their owners: Aeroflot, Yakutia, and so on. All which is nobody rowing monoplane showed how passenger a chief designer told us about planes construction, interior, and special design. For example, air frozen system, planes wings, air formation. We thought we could touch a real plane. We saw his parts from the inside. I was impressed and found out more information. Let's look at the table. According to the data, we can see that it is really competitive. That's all.
Thank you, Marilo. The next step of our excursion was so that we went to the conference room where a real pilot tester told us about experiments which were held with Superjet. Well, why do we need such experiments? First of all, we need them to understand how to develop the plane, what are its good points and bad points, how to make it better. And another point is to get certificates which can allow plane to work, to live his real life, to transfer people from one place to another, because it's not possible to do without special documents. And now Mikhail Alexeyenko will tell us in more details about tests which were held.
Good day, ladies and gentlemen. The first test flight of Superjet was executed on the 19th May 2008. Since that moment, a great amount of tests were held. Looking for specific weather conditions, Superjet flew over the world. High altitude test in Mexico, test on the side wind in Ireland, and on natural icing condition in Arkhangelsk. One of the most handsome tests were tests of energy protection from the water from the airfield strip. They were held at the Flight Research Institute airfield. A special pool with the depth of 4 centimeters and the length 70 meters was made at the airstrip. All in all, 27 scampers were implemented with different engine behaviors and different velocities. Test results show that aircraft can safely take off and land on the trip filled with water, and its engine location excludes the increase of the water in them. On the 3rd of February 2012, received an international certification in foreign countries can explain aircraft. Thank you.
Thank you, Mikhailova. Well, and then there was the last but not least part of our excursion. We saw real simulators, plane simulators of Superjet, and some of us tried to land these simulators. Fortunately, these planes were not real, that's why we are here and we can talk with you. Some of tries were successful, some not very, but anyway, everybody could feel that he's a real pilot. And now some more words about it from Alexander Minko, who liked these simulators.
I think that the most interesting part of our excursion was visiting the flight simulators. We saw the simulators for training, full flight simulator and simulator FTD, stational simulator with which we saw the first. This simulator was made for retraining pilots and their periodic trains. I can tell you that I won't forget the feeling of flight on Superjet in this simulator. It was really interesting and impressive. Of course, I controlled it not only by myself. The whole flight, test pilot Chikhanov Leonid helped me. Other simulators we saw too, but unfortunately we couldn't test them. We will tell some facts about them. The full flight simulator is made for pilots. They can practice action in emergency situations. It simulates normal, complex and difficult flight conditions in real time. You can fly at any weather and at any time of the day. The simulator of emergency rescue training consists of the crew cabin and the front part of passenger cabin. It was designed for efficient crew training to save passenger and emergency situations.
Oh, thank you a lot. And in the end of our presentation, I'd like to tell you what did impress me much more. You know, planes and factories, all these things are great, but nothing can work without people, and all these things are created by people. So, to tell the truth, I was impressed with these workers who created Superjet, who just made it fly. And there was such situation when the chief designer told us some facts about aircraft. He told that one of them is in Tagi and it is to be broken because this is an experiment. And to tell the truth, I saw something like tears in his eyes because he understood that his child will die, but it will die because he had to die to let other planes fly and work. That's why I'd like to thank all people who make planes fly, who makes all this world work, and thank those who let us to go and see real planes and meet these people. At the end of our presentation, now we are happy to answer all your questions.
For how long does the plane get tested before having its first flight, maiden flight? So do you know?
I think Maria can answer this question.
I can. The first plane was assembled in 2007, and I think for about 7 months it was just running on the airfield and testing his engines.
Also, in the conference room, we were shown a video on that, yes? So, and do you remember what kind of tests?
Yeah, the test that impressed me was the test to find the minimum velocity of taking off. It was really cool because plane was trying to fly, and he even just tried to touch the ground with his tail. And I really like this experiment because it was beautiful, I think. Then there were, as she told us, that there were some experiments connected with what experiments? Experiments with water. So how water can is it possible for water to be in the engine? And some sorry. Yeah, the interesting experiments connecting with antifrothing systems when they put special blocks which were like ice. They put it on wings, and the plane had to fly with these ugly things. But as chief designer told us, the plane could fly even with ice on his wings because it's really good designed. So like this. Yep.
May I ask a question?
Yes.
Can you show the slide from the first slide? This. Do you know what is it?
As far as I know, it's a special.
Medium formed out.
It was, and now the prediction, the next one. This detail is absent.
Yeah. Just Chief Pilot, not pilot, designer told us that sometimes we put special cameras on the cabin, and sometimes they use this special mesh to take information from plane.
It was the first slide. Our chair of computational simulation took part in the contract of Bill Sukhoi, and this work was related with location of pressure gauges, which made it possible to develop this test device. And now pressure gauges are located in the nose part of the
Much more useful.
work of optimization of pressure gauges. This picture is one. The water. Do you know that student from chair of Flight Research Institute took part in this work?
Now we know.
I have another pictures related to another aircraft, but small explanation about construction of this device for simulation of landing on aircraft on the wet landing strip. And the last question, Oля, for you. You impressed working on a flight simulator. What do you think about real flight on the aircraft as a pilot?
It must be great because just several months ago I understood that I like planes, but time passed and now I understand that I'm crazy about them because I really liked the simulator. I liked to touch planes. I liked the people who are dedicated to their job. Now I understand that this place is really for me because I like all these things. It would be great if I tried to fly.
So our student who will study at Flight Research Institute group will have opportunity to take part in the flight test on the aircraft.
It would be great. So, any questions?
Well, thank you for your presentation.
The Central Hydrodynamic Institute is a recognized leader in the aerodynamic design of fans and compressors of different ships and sizes.
Hello, ladies and gentlemen. Let me introduce myself. I'm a student of Dave Meek, the Department of Aeromechanics and Flight Engineering of Moscow Institute of Physics and Technology, from group 263. And in the next 5-10 minutes, we are going to tell you some information about CAGI, Central Hydrodynamic Institute. And if you have some questions during our presentation, please hold them until the presentation ends. Okay, our presentation consists of several parts. Here you can see the plan on the screen. And first of all, we are going to tell you a little bit about the history of CAGI. There just will be the main dates and events from the foundation until our days. And then there will be some information about that will show you what CAGI is today. Here will be shown the main activities of the institute. And the last part is in conclusion. Here we will express our opinion about the excursion and about everything we saw and heard there. So, and I would like to introduce my colleagues, Marenko Valentin and Khairul Nail, who will go on this presentation, and according to our plan, we will tell you about the history of CAGI from the foundation till our days. Please.
First of all, I'm very glad to greet our esteemed guests and thank you for your attention. People will fly without relying on the strength of their muscles, but on the strength of their mind. these famous words of Nikolai Igorovich Zhukovsky, the Russian scientist, founding father of modern aerohydrodynamics. Whereas contemporary scientists scoffed at the idea of human flight, Koltsov was the first to undertake the study of airflow. So according to this words, there was a need in such powerful scientific establishment. The Central Aerohydrodynamic Institute was founded in Moscow on the 1st of September in 1918 by Nikolai Igorovich Zhukovsky. The institute built its first large wind tunnel in 1925. In 1935, a new department of Tsagi relocated to the outskirts of Moscow, to what later became the town of Zhukovsky, the outer city of Soviet Union. The first two wind tunnels were completed in 1937, and by 1939, Tsagi became the proud owner of the largest wind tunnel of the world. This wind tunnel provided the opportunity to study the behavior of full-scale aircrafts. In the following years, Tsagi became the founders of leading aerospace research institutions and design centers, such as the Institute of Aerospace Materials, the Institute of Aviamotors, the Tupolev Design Bureau, and the Flight Research Institute.
During the war years, Tsagi resources were directed military aircraft application. In 1943, Tsagi introduced a new transforming wind tunnel capable of using variable and constant density testing agents. Tsagi developed a new concept of wing profiles, wing components and compositions, plane stability criteria, rand standards, and flapless error. The post-war period was characterized by research of near and post-sonic speeds. Since the 1950s, Tsagi has been involved in all areas of fundamental researches and in aerodynamics, flight dynamics, flight stability, and strength. Afterwards, Tsagi also participated in developing the Energia launcher and the Buran reusable airspace plane. Tsagi made significant investigation into aerodynamics and flight dynamics, accessing structural strength for velocities from orbital to landing. There have been done great researches which were used in many projects of airplanes. So, for all periods of existence, Tsagi has been providing the aircraft power of our country.
Thank you very much, Valentina and Nail. And about the modern Tsagi, Karakin Narek Rashid Vladislav will tell us. Please.
Good morning. So what is Tsagi today? Tsagi has not, virtually Tsagi has not changed much in the last years. We will not go into mature details because firstly, Tsagi is a secret object. Let's look on basic points. Tsagi cooperates with more than 50 leading foreign aerospace companies and research centers in America, Europe, and Asia in the field of theoretical and experimental research. For the last 10 years, the Institute has carried out more than 300 contracts and grants. As a sponsor of the Institute, there are more than 60 wind tunnels and test stands for study of strength, acoustic, aerodynamics, dynamics, and dynamics of aircraft. All of these wind tunnels and test stands are in great condition. Tsagi also put a lot of Tsagi also put a lot of effort to sustain all of the equipment on high level. So recently, all computing equipment changed on modern. Significantly reduced the number of employees from 14,500 to 4,000. Formed HQ. But now Tsagi still have world-level scientists and great specialists.
And now I will tell you about some information about wind tunnels. Complex of aerodynamic wind tunnels units have more than 60 facilities providing simulating of flying conditions of speed at 10 meters per second and mass number about 25. The first one is one tunnel T101, allow testing of large size models of heavy aircraft and the study of aerodynamically, stability, controllability, and the flutter of different aircraft at subsonic speeds. In subsonic wind tunnels T102 and T103 conduct research on the aerodynamically similar models of a wide range of characteristics of the aircraft for different purposes. In the vertical wind tunnel T105, it used to study the characteristic of helicopters models and study the spin of the aircraft. Supersonic aerodynamic wind tunnel T108, T109, 13 and 14 are designed to investigate of supersonic aircraft muscles. These all wind tunnels help to study the aerodynamic stability and control, flutter, reverse, object sharing, the aerodynamic of power plants in a wide range of Mach number. Some of Tsagi wind tunnels one entry in the Guinness record book. This includes full-scale subsonic wind tunnel T101 and transonic tunnel T128, supersonic tunnel T116, and hypersonic tunnel T117. Interesting that something of units in Tsagi have no analogies in the world. For example, it is SMGBU with magneto-aerodynamic flow acceleration to speed for 8,000 meters per second. Or, for example, UGSD is with multiplier pressure, which reach the pressure in the stomach chamber to 5,000 bars.
Thank you very much, Rick and Vlad. And now Kuzin Sergey will speak some words about excursion to Tsagi. Please.
As you know, there was Open Doors Day in Tsagi, and we were lucky to attend an excursion. First, we were shown a short film telling us about the most significant events in the history of Tsagi. And after that, we visited the biggest wind tunnel in Europe. We found this wind tunnel amazing, and we were surprised that it was built in 1939. We also saw modern flight simulators. One of them has moving cabin. It gives much more convincing experience of flight. Thank you.
Thank you very much, Sergey. And to sum up, Tsagi still remains one of the most significant scientific centers of Russian Federation, which always comes with innovative ideas. And we are glad that we visited the excursion and have seen a lot of interesting things there. So our presentation comes to the end. Thank you for your attention. And if you have some questions, please ask them now.
So, what else except planes is it possible to test with the help of wind tunnel?
Okay.
No, what else except planes?
What else?
Yes, that's all.
We know that some buildings will test there. For example, a bridge, you know, to Moscow, and this statue. I don't know exactly how it's named. By and these investigations help to make it more safe and more stronger.
Nice question. Seriously, please show small pictures. The Pentano T106. This? No. Sure, this. Just not Pentano, question for this. Is it Sagi? No. Sagi to say. It's not Sagi. And T106, maybe. It's the first one. Right? Okay. Oh, this. Who knows what is it origins or what it's done?
Air. So
to cause air inside.
So is this transonic Pentano? Do you know?
Yes.
Yeah. And without these origins, we have no opportunity to go through Mach number 1. Yeah. It was well-known academician and scientist Sergei Alexeyevich Kristianovich, who received Stalin's honor for this work, and he was unique scientist. He had 6 medal of Lenin. So 6 medals of Lenin, 1 person during 15 years of work in science. This? No. The next. T105. Do you know why it's necessary to locate vertical?
We have set to test the models of helicopters and to investigate the spin of aircraft.
Spin.
Yeah.
So, free-flying model who can drop in the wind tunnel. And do you know that in this tunnel were made experiments with parachute? Person without parachute with special clothes in free flying in the flow.
Oh, we didn't know.
No. For me.
Was it successful?
Yes.
Experiment.
Velocity is not enough to simulate the normal suit, so they have increased suit to be very fat and fly in the vertical flow in the test section. Here was located grid, this and outside the test for safety of this person. So it was person from our parachute team, Russian team for championship.
Thank you.
Thank you.
Please.
In the wind tunnel to 128, there are little holes in the walls. Can you tell us what are they made for?
How I understood, this made to let the wind go out the wings of airplane to allow people have good results of testing. Because if there are no such holes, it will just connect with the walls, and it will make some progress with results.
So also you have mentioned Buran, one of the greatest Tsagi creations, and do you know the reason for creating it?
People suppose that it will be much cheaper to use reusable aerospace plane. So it was made to prove that, but in fact it was much more expensive.
But there was one more political reason.
Maybe like an answer to American shuttle?
Yes, space shuttle.
Thank you for the presentation.
Our dear guests and our students, today we have 4 presentations about Tsagi and about Sukhoi. And first I'm going to tell you a few words about them. Some time ago, our first year students had a very interesting experience. They had 2 excursions to Tsagi and Sukhoi. So now they have an opportunity to make presentations about these enterprises. Each group was divided into 2 parts, and one part of the group made a presentation about Tsagi, and another part of the group made a presentation about Sukhoi. So today we have 2 groups. It is group 264 and group 262. And so we will listen to both presentations, and the first is group number 264, and the presenter is Nastya Zakharevich. So you're welcome.
Good afternoon, ladies and gentlemen. My name is Anastasia Zakharevich, and I will be a presenter. Let me introduce our team. We are students of Moscow Physics and Technologies Institute at the Faculty of Aeromechanics and Flight Engineering from group number 264. A couple of weeks ago, we went on excursion to the Central Aerohydrodynamic Institute named after Zhukovsky Tsagi. And now we would like to share the information about it. Our presentation is divided into several parts in which we will tell you about the history, activities and achievements of the Institute. Our talk will last about 10 minutes. After the presentation, we will be glad to answer your question. And now, in the first part, Alexander Spekhov will tell about the history and organization structure of Tsagi.
The founder of Tsagi, Nikolai Zhukovsky, was a professor at the Imperial Higher Technical School at Moscow State University. Mr. Zhukovsky's theoretical research in the sphere of aviation, practical experience in wind tunnel construction, and the research carried out at these laboratories gave rise to Russian aviation science. In 1918, Mr. Zhukovsky's students persuaded him to propose the establishment of a complex scientific center in Russia. On the 1st December in 1918, the Central Aerohydrodynamic Institute Tsagi was officially founded. Before the Second World War, Tsagi worked intensively in cooperation with design bureaus and factories to further the progress of aircraft manufacturing. The advent of high-speed monoplanes in the mid-1930s necessitated expansion on the Institute's experimental base. Construction of a new complex of experimental facilities began near the Odekhovo station on the Moscow River in 1935. The Institute's scientific contribution is indisputable, and the name of many Tsagi specialists are emblazoned in the history of world aviation. A reasonable combination of practical work and fundamental research provided, and foundation thanks to which Russian aviation retains world leadership in a number of fields, even despite the protracted crisis on the defense industry.
Thank you, Alexander. Now I would like to invite Yuri Fadeev. He is going to tell about aerodynamics.
Aerodynamic research of aircraft, helicopters and other aerial vehicles
is a key sphere of the Institute's scientific activities. TSAGI experts carry out theoretical research into scientific problems, study physics, shape aircraft design, and develop aerodynamic configurations for prospective aircraft. TSAGI uses wind tunnels in physical research of theoretical flows and models of aircraft. TSAGI has developed an optical system for pressure measurements in steady and unsteady flows, using both computational and experimental methods. TSAGI cooperates with design bureaus to develop aerodynamics configurations for different aircraft.
Thank you, Yuri. The next speaker is Edward Poiter. He will tell about the Strength Research Laboratories.
Starting from the inception of domestic aviation, TSAGI became the fundamental institution enabling systematic research into aircraft training. The Institute's fundamental theoretical computation and experimental to analyze and systemize flight test results is being used in main organization and the Institute for certification of aerial vehicles. In order to develop safe and reliable products, TSAGI carries out theoretical and static thermal strength experiments. TSAGI specialists have developed an advanced method of researching aircraft behavior in subflat conditions. They advanced in elasticity in subsonic, transonic, and supersonic wind tunnels. The Institute has formulated many algorithms for calculating aerodynamic and hydrodynamic. The Institute addresses the problem of achieving high parameters through extensive research, which comprises development of a method for local stress strain, service life, and research in strength of materials.
Thank you, Edward. Now I want to give the floor to German Stanislav, who will tell about effective design.
Research into the flow aspects of aerospace development based on an effective design solution. Universal methods and automated aids are widely applied, as well as special automates for multidisciplinary designing of aircrafts of various types, developed by TSAGI departments. Continuous development of aerospace allows the Institute to improve the parameters of passenger and cargo aircrafts from generation to generation. TSAGI research new ways to further aircraft technology, including development of non-trivial designs that might bring about a breakthrough in this direction. One of the Institute's primary lines of research is testing of flow signature method with the use of advanced technologies. Researching the prospects of aerospace technology development also includes the search and evaluation of new technical solutions that might bring us to the new generation of aircrafts.
Thank you, Stanislav. I would like to invite Boris Vecherkin. His speech will be about fundamental research.
Thank you very much. Firstly, I'd like to say that TSAGI scientists hold a leading position in the realm of high velocity flow theory. With their achievements, recognized a number of principal fields such as analytical research of supersonic and hypersonic flows over bodies, study of flow separation phenomena, laminar turbulent transitions, research of heat transfer and methods of thermal protection. Also, TSAGI performs a wide range of research in fluid and gas mechanics. Phenomenal progress has been achieved in the development of numerical methods and calculation programs for ideal and viscous flows over aerodynamic profiles and bodies of revolution in a wide range of velocities for the internal flows and boundary layer parameters.
Also, Tsagi developed mathematical models for flows over aerial vehicles, flows in air intakes and nozzles, and jet outflows. The Institute performs environmental research for the purpose of minimizing jet aircraft and rocket engine exhaust and reducing their influence on atmosphere. This advanced research in wide range of disciplines became possible thanks to highly qualified scientific personnel and unique test facilities. Thank you.
Thank you. The next speaker will be Sergei Kolesnikov, and he will tell about hydrodynamics and aeroacoustics.
Hello. Tsagi has been developing as a science ever since the Institute foundation. For example, in 1930, the Institute opened a 40 channel for testing hydroplanes. All Tsagi hydrodynamics specialists until the issue of recommendations for safe teaching of passenger aircraft. Institute personnel have conducted a comprehensive study of hydro and aerodynamics of various wind-driven vehicles, hovercrafts, and hydrofoils. Tsagi began active acoustic experiment in the late 1950s due to the necessity of reducing noise produced by passenger aircraft. The problem of noise reduction for existing and prospective aircraft gave birth to a separate branch of aerospace science, aeroacoustics, which is closely related to aerodynamic and acoustics. Thank you.
Thank you, Sergei. Now I call in Nadezhda Subairova. Her report is about information technology.
Hello. One of the most important areas of information technology supplies in Tsagi is development of research in aerodynamics for aircraft. Due to it, the conditions are created for the realization of multidisciplinary studies by interacting between the specialists and the soft hardware complexes. The well-known computational systems developed by Tsagi specialists in principle of aeronautic directions are widely used in studies. The complexity of the research are provided by integration scientists' working place into the uniform computer network. Currently, the results of aerodynamics tests are formatted automatically into electronic atlases. The preparation to the experimental tests is also automated. It includes the drafts, the design, and the manufacturing of experimental model. Mathematics of computation and experimental research constitutes one of the large within the cycle of development and production of aeronautic equipment. Thanks for your attention.
Thank you, Nadezhda. And now Artem Bagalyan will tell us about the benefits Tsagi for the national economy.
Tsagi uses its WIME channels for comprehensive model and sample testing aimed at finding optimal shapes of all types of ground vehicles, rolling stock, underground trains, and hovercrafts. The Institute also researches into wide stress on tall buildings, bridges, and large cases, and seeks environmentally optimal variants of urban development. Introduction of the Institute's research results is exemplified by the Poklonная Gora Victory Monument in Moscow and the bridges over the Bele, the Ob, and the Moskva. Tsagi is a recognized leader in aerodynamic design of fans and compressors of varied construction and dimensions.
employment of calculation methods and utilization of unique test benches, advanced computing hardware, and developed sets of mathematical models guarantee the creation of highly efficient fence with optimal configuration in terms of dimensions, weight, power consumption, and acoustic requirements. Thanks.
Thank you, Artyom. And that's all we wanted to tell. In conclusion, we would like to thank the faculty for the opportunity to visit Tsagi. If there are any questions, now we are ready to answer them.
What do you think, how many wind tunnels in Tsagi? Your estimate?
Maybe more than 10 tunnels.
95.
95.
And how many are in use?
95.
No. About 12. So you have great opportunity to restore these tunnels in the future and be chiefs of very nice tunnels there. Work there and build up labs and so on and so forth. We need young people for this.
Well, you have told a lot of information about Tsagi and its history, and now I would like to know about your emotions, and maybe you would like to do work there after graduation.
I think working in Tsagi can be rather interesting. The most interesting in our excursion was maybe one tunnel 101st and 104th. It has, they have great size for about 25 height and 14 or 15 in length, if I'm not mistaken. I think everybody who was there was really impressed by them. That's all.
My question to any of you. So what career opportunity does Tsagi provide with its young and not very experienced employees? Maybe you know something about the average salary? So you were told, as far as I remember.
I know that the salary for young people is about 1,500 rubles. No, 50.
50,000.
50,000, yes.
1,000 rubles. Okay. What other career opportunities except salary?
I don't know about it. So that's all.
That's all, thank you.
Thank you for your attention.
Good afternoon, ladies and gentlemen, students and teachers. My name is Andrei. I and my teammates are the students of Moscow Institute of Physics and Techniques, the Department of Aeromechanics and Applied Engineering. We are glad to see you on our presentation. Today we plan to tell you some words about Sukhoi company and its new creation, Sukhoi Superjet 100. We decided to make this presentation because we have visited this company some time before, and we are obliged to our faculty, this company and the Department of Foreign Languages for the chance of presenting there. All the presentation will not take more than 15 minutes, and we divided our presentation into 5 parts. In the first part, we will tell you some information about the history of Sukhoi. After it, we will say some words about the researches and development and manufacturing activities. Next, we will pay attention to the history of creation of Superjet. In the first part, we'd like to present you Sukhoi Superjet.
After it, one of us will describe how difficult it was to get some certifications in different spheres. At the end, we are going to say some new projects of the company. There will be plenty of time at the end of our presentation to now the company is implementing innovative projects in the sphere of military and civil aircraft. Now my teammate Ivan will tell you some words about its history. So Ivan, you are welcome.
Okay. The original Genstock company Sukhoi Design Bureau dates back to team number 4 of Tsagis Agos. The team had been owned by Pavel Osiprovich Sukhoi in 1930. The government's resolution of 29th of July appointed Pavel Osiprovich chief designer. He, together with a team of design bureau, which have been given standalone status, was relocated to production aircraft plant number 135 in Kharkov. It was the beginning of a new independent company under the name Sukhoi. Sukhoi, Ivanov, Simonov, Gasyan were the heads of this company in different times, and under their guidance and aircraft building experience of the construction bureau, bureau team made it possible to produce a family of aerobatic airplanes such as Su-26, Su-29 and Su-31. With these machines, the national aerobatic team of USSR and the Russian Federation have won a lot of European and World Championships. Okay, let's have a look and watch a short video. This was wonderful, isn't it? Okay, let's return to the presentation. Now Igor Yakovlevich Ozar is the head of Sukhoi company. At the beginning of the 19th, the design bureau team decided to integrate work on civil projects. In year 2001, we saw the first flights of civil transport airplanes Su-80GP and agricultural Su-38 airplane. Sukhoi civil aircraft is currently engaged in developing a family of regional airplanes.
Thank you very much, Ivan, for such interesting and informative information. However, everyone knows that a big company should have a big plan. So, let's come to know them, and my friend Sergey agreed to say.
Thank you. The first of current activities is their development and manufacturing of prospective combat aircraft for frontline aviation. The second is the progressive development and large-scale upgrading of multi-role fighters. Next, diversification of production through promotion of civil aircraft manufacturing in compliance with the international standards, and a wide range of after-sale services. Incorporation of cutting-edge technologies into R&D and manufacturing solutions. Adoption of online design procedures, introduction of pioneering manufacturing methods based on CAD technology. Then introduction of single quality and pricing management system. A reduction of time to market and the cost of new aircrafts and equipment for them. And the last is complex modernization and upgrading of their holdings of manufacturing facilities.
Thank you very much, Sergey. It was very informative, but we are moving on the most interesting part of our presentation. So let's talk about financing. It is common knowledge that the face of a company is its production. So let's have a look on new Sukhoi creation. I wonderful girl Tanya agreed to say some words about it.
Thank you. By the beginning of the century, civil air operations in Russia implemented an fairly obsolete aircraft. So open airlines had to purchase their foreign equipment. Then the company Sukhoi decided to develop a commercial aircraft. This project was named the Russian Regional Jet. It was intended to replace the aging Tupolev Tu-134 and Yakovlev Yak-42. For this purpose was formed the joint stock company Sukhoi Civil Aircraft. The development of the Russian airliner named Sukhoi Superjet was provided in cooperation with the American Boeing, the French Snecco, the Russian Saturn, and other corporations. In 2005, the city of Komsomolsk-on-Amur opens a manufacturing department of Sukhoi Civil Aircraft. And 1 year later, the first Superjet was assembled. In the January of 2007, it was brought to Zhukovsky for static testings.
Thank you, Tanya. Now I want to present you another my partner, who will tell you about the tests which this plane had overcome.
Thank you. Sukhoi aimed to satisfy all European demands, so it was obvious that he was going to overcome a lot of tests. Even our French colleagues joined us in 2007, while the test was started in 2008 to have the preparations. Many parts were borrowed from European and American producers, but the whole construction, especially wings, were tested not once. I'm talking about those standard and very important tests like ice formation and side wind, which was held in Iceland. And of course, statistics trench test, where loads were 1.5 higher than the practical limits. By the way, the plane suffered so many tests that finally it collapsed. And all these tests show pretty nice results, in fact. The heart of the plane, the engine, SAM 146, constructed and built in Russia, was qualified really strict to get the certificate. The concept of the test was in throwing any possible stuff which can be found in the sky into the engine. This is ice, birds, and whatever they liked. And the thing is, no matter what happens with the engine, the traction mustn't fall more than 1.5%. And fortunately, the engine passed the exam, so everything was okay. To sum up, the plane Superjet spent more than 2,000 hours in more than 800 flights. So that's a great number.
Thank you, Vlad. So, we are on the end of our presentation, and finally, let's hear some information about new projects of Sukhoi company. Sasha, what are your
In 2010, the head of United Tech Corporation and Mikhail Purgasyan said about the perspective of creating the new wide-body aircraft. It's the first wide-body aircraft science built in 1996. an example of narrow body characteristics, help us area of 320. There are many differences between these two types are question capacity and data change, and this step will based on question that 100 and it were in 2016. So site also have some information about their projects, such as vertical track QAP. They build this include unidirectional press base, dynamic research, and that graphic conceptual but no steps or projects details are non-known.
Thank you very much, Sasha. At the end of our presentation, I'd like to say some words that now Sukhoi becomes not only a military airplanes company, and now this company is involved in the game of civil aircraft, and Sukhoi Superjet is a confirmation of that. After the integration of all companies under one name, I hope that this company will become a center of airplanes in our country, and to that I want to say thank you very much for your attention. We are ready to answer questions.
I've got a question to Vadim from class, who told us about Sukhoi Superjet 100. So, of course, it looks fantastic, and I really appreciate the work which has been made by specialists of Sukhoi. But anyway, does it have any flaws to correct in the future?
Of course it has. There is a lot of unknown areas in aerodynamics at all. So scientists have a lot of work to know how, for example, different forms behave in the air. It's a great work, so the future is great.
Okay, but anyway, let's return to Superjet 100. So, does anybody complain about?
No, if it have passed all European certificates, exams, that it says something. More questions?
Okay, I have a question to all of you. What impressed you most of all during the excursion?
That I couldn't find a piece of dust in such a huge building. That was impressive.
The most impressive thing?
It was so clean. There was
I think I want to answer the question of the exam. I think that the most impressive thing was some tests on Superjet, and the fact that all the people there were very sociable, and they talk to us in an easy way. They told us a lot of information about Sukhoi Superjet 100, and of course it was very knowledgeable when you can see different details of this plane, because they were open and there were some tests on them.
Okay, thank you.
Have you seen any fish tanks there? Former students of respect.
What would you like to say?
No. Are there any former students of Moscow Institute of Physics and Technology in Sukhoi company? Have you seen them there?
I don't know. They hadn't told.
And is there any room for you guys in their company?
But I know the information is that there are a lot of students of our department there. And maybe the father of Masha Chikunova is our educator. No? So I'm making a mistake.
And another question. Do they work on supersonic transport? Right?
Yes. With
What
fighters.
kind of
With fighters.
supersonic transport? I mean, for
No.
civilians.
No. They plan to do it.
Thank you.
Okay, that's all questions. Thank you.
Shall we start? Yes. Well, good afternoon, student guests. I would like to start our presentation by introducing our team. We're students from Moscow Institute of Physics and Technology, the Faculty of Pyromechanics and Light Engineering, from the group number 262. Today we're going to talk to you about the Central Aerohydrodynamic Institute. The purpose of our presentation is putting in touch you with the information about SAGI and with the history of the Central Aerohydrodynamic Institute. Today I'm going to announce our presentation. My name is Yakovleva Marina and I'm very pleased and proud to be here today. So I have broken my speech into some parts. The first part will be about the general information. The second part is for the history of SAGI. The part number 3 will be about the test facilities. The part number 4 will be about the main directions of activity in SAGI. And the last part is for conclusion of our teamwork. I asked you to save your questions for the end of our performance. So last week we visited the Central Aerohydrodynamic Institute. The south. Our presentation it is a result of our small trip into the mysterious and exciting small planet of aviation. So now let us turn up to the point number 1. It will be about the general information about the SAGI. So please,
Today, SAGI is the largest scientific research center in the world. In 1994, it was designated as state research center. It was the first scientific institution which is combined basic studies, flight research, functional design, pilot production, and testing. During its history of SAGI, exploration, stability, controllability, criteria, and strength requirements. SAGI was a pioneer in the theory of fluttering, along with other theories, applications, and experimental studies.
Thank you, Konstantin. Now let us move on to the second part. It will be about the history of SAGI. So please congratulate Sonia and tell us.
Good afternoon. SAGI was founded in Moscow in 1918. In the 1920s and 30s, projects of SAGI ranged from prototype airplanes to airplanes, and from torpedo boats to wind-generated electricity. Gradually, the main direction of SAGI SAGI evolved and centered upon aerodynamic research. The institute built its first large wind tunnel in 1925. In 1935, new departments of SAGI were located to the outskirts of Moscow, what later became the town of Zhukovsky, the Irish city of the Soviet Union. The first two wind tunnels were completed in 1937. During the war years, resources of SAGI were directed toward military aircraft applications. The post-war period was characterized by research on near and post-sonic speeds. Since the 1950s, SAGI has been involved in all areas of fundamental research in aerodynamics, flight dynamics, flight stability and strength.
Thank you, Sonia. Your report was very exciting. And so the part number 3 will be about the test facilities, and the expert in our team group is Nazimov Sanjay.
Test facilities include complex of wind tunnels, gas dynamic research installations, static and dynamic strength laboratories, thermal strength, acoustic cameras, propulsion and compressor test benches, flight simulators, air power generating complexes, experimental production facilities. I will give more details about wind tunnels. T101 and T104 subsonic wind tunnels can be used in testing large-sized models of heavy aircraft and their details. T105 vertical wind tunnel is intended to test helicopter models and research into aircraft speed parameters. Some wind tunnels merit an entry in the Guinness Book of World Records. This includes T101 subsonic wind tunnel with its 14 by 24 meters test section, T128 transonic wind tunnel with 2.75 by 2.75 test section, and T116, T117 super and hypersonic wind tunnels.
Thank you. And now we're going to hear about the main directions of activity in SAGI. About this will tell us Roman.
Good afternoon. The first branch is aerodynamics. SAGI continues to develop cutting-edge aerodynamic technology. It makes integral solutions for problems available for mathematical simulation, design work, and experimental studies, followed by the optimization of the elements, then complete aerodynamic layout. The aim is to form optimum aerodynamic shapes of subsonic, supersonic, and hypersonic aircraft of various purposes. The second branch is strength. SAGI can help to solve structural problems in certification, operation, and development of aircraft and spacecraft, advanced high-technology transportation system, high-rise buildings and constructions, and underground communication. The third branch is aeroacoustics. The aeroacoustics research in SAGI is focused on the development of the research of the development to achieve a needed level of aircraft, a needed level of ecological safety of Russian advanced medium-hull aircraft in respect to environmental aircraft noise and the sonic and aerothermal-ventilated comfort of the passenger and the crew cabins. The next direction is hydrodynamics. A hydrodynamic branch specializes in the study of high-speed movement of the bodies over the water surface, under the water surface, as well as close to the boundary of the mediums. One more direction is flight dynamics. The main direction in flight dynamics are the development of requirements for aircraft stability, controllability, and control systems. experimental investigation of a new aircraft dynamics unit flight simulators, the development of new methods of partial full-scale flight simulation, and the development and integration of new experimental facilities. And the last branch is measurements. Tsagi possesses a variety of unique developments and special standards. For the first time in Tsagi, scientific and technical base of strain measurements was developed, thus providing the main types of measurements inside the experimental facilities and in a number of organizations of aviation and machinery industries.
I'm so grateful to you and for your report. And now to sum up our performance, I'm rushing to conclusion.
Good afternoon. Tsagi is a leader in aviation theory and experimentation. It has extensive experience in designing aircraft and third traditions in comprehensive scientific research. Its engineering staff has a continuous influx of talented people prepared in unique educational programs at leading scientific Russian universities such as the Moscow Institute of Physics and Technology and Moscow Aviation Institute. Over the last several years, Tsagi established contacts with a majority of research and development centers and aircraft manufacturers in Europe, the United States, and Asia.
Thank you. It was all for today, and I would like to finish our performance by remembering that Tsagi is the most challenging organization in Russia, and I hope that Tsagi, with the help of the Tsagi, Russia will achieve new tops in aviation. So that's all. Thank you for your attention, and if there are any suggestions or comments, please tell us. We are ready to answer.
I have a question to all of us. To all of you, sorry. Let's say you are in Tsagi. What would you like to do there? Numerics, experiment, theory, or something else? Just one by one. It's for everybody.
If I were in Tsagi, I'd like to work with the one-wing tunnel. As I saw, there was an enormous control panel, which is when one person controls it and do some tests with models, and it is really interesting. I'd like to do this.
As for me, I think that it will be interesting to do some works with the measurements, maybe, or of course, I think it will be more exciting if you work with the wind tunnel. We were in the tunnel number T101. It was really amazing. It was so big, and there you go, something like ants. You're moving there, and it was really exciting for me. Well, another opinions, please.
Go ahead.
It's was working inside. Well, maybe some other questions.
Yeah, I have another one. Do you have any idea about social activities there, especially for young guys?
Human social activities like sport or some conferences, no?
Yeah.
National conferences. I suppose they're born nowadays some social life without us, and so I think teamwork there not too so.
Now I tell you about the Olympic Games every year, once a year. They have so-called Olympic Games, which includes two disciplines: volleyball, football, basketball, badminton, and what? And Ping pong, yeah, small things.
I suppose we are ready to present.
Good.
So what researches have been carried out by SAGI specialists recently? The latest
When we visited the internal 109, we weren't allowed to go in because there was some experiments, and we were said that it is the government secret. So they do something.
Okay, this was all. Thank you.
I believe this is great stuff, guys. You did just terrific job and very good slides. Only one comment. Please improvise. Don't try to make as smooth as possible the presentation. You should do some mistakes. You should move. You should do something. Not just boom, 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 boom. Thank you. No, it doesn't work this way in conferences. Very interesting case from my experience. It was some conference, and this stuff was broken for some reason. Guy, American guy, he started to fix it. So he take this position, do this about a few minutes. So people sit and wait. Yeah? Then some operators came and they started to fix this. And this guy said, okay, we have time and we don't have slides, let's sing. And he started to sing some very famous song, I don't know. And he did it from the beginning up to the end. Nobody helped him in this, but he did it perfectly. And after that lights showed up, and he started his presentation. So you should be ready for different kinds of situations, and try to keep audience involved, and try to point out on your slides and say something. When you have a movie, comment this, not just keep quiet. Okay? And again, very good start, and please proceed with this. I believe you will do a very good job in the future.
Please, 264 and the presenter is
Good afternoon, ladies and gentlemen. My name is Denis Kleif, and I will be your presenter. Today we're going to share some information about Sukhoi company. Before we start, I'd like to thank our guests for attending this event. Our presentation is divided into several parts. Firstly, we will give you some brief information about Sukhoi. Then we will reveal you some history of the company. After that, we will move on to the Russian regional jet Sukhoi Superjet 100. And after that, all the questions will be welcomed. Now Artemy Borodin will begin with the first part.
Thank you, Denis. Sukhoi is a Russian major aircraft holding company employing more than 26,000 people. 100% of stock of the Sukhoi Aviation Holding Company belongs to the United Aircraft Corporation. The company supports a complete cycle of work in aircraft engineering, from front-end engineering to comprehensive after-sales support. The holding's products such as Sumark combat aircraft are state-of-the-art weapon system in the global market, which forms the backbone of the frontline aviation of Russia and tactical air forces of many other countries. The company is Russia's major manufacturer of export aircraft, placed third in the world in terms of the numbers of modern fighters produced. The company is currently implementing promising programs in the field of military and civil aircraft engineering.
Now let's move on to the second part of our presentation, and it will be Indorezov Maxim and Shapovalov Vladimir who tell us the history of the company.
The origin of the Sukhoi Design Bureau dates back to team number 4 of Central Aerodynamic Institute, Airbus Aviation, The team having been taken over by Pilotsevich Sukhoi in October of 1930. And the next 9 years saw the team produce some of the experiment fighters such as E-3, E-14 and others, and some well-known aircraft such as the record-breaking RD, which was used by the crews of Valery Pavlovich Chkalov and Mikhail Mikhailovich Gromov to perform a number of extremely long-distance flights. And in the beginning of 1945, the design bureau was engaged in development and building of such the other system of naming airplanes such as Su-9, Su-11, the 5 post-war years, so the Sukhoi Design Bureau developed and introduced such innovations as landing braking parachute and other ones.
Vladimir, continue.
The year 1969 saw the maiden flight of the frontline Su-24 bomber with rivals with winch, the first Soviet all-weather-type aircraft. The Su-24 was produced in several versions. It's currently in the inventory of the aircraft of Russian Federation and number of other countries. The year 1975 saw the maiden flight of the armored Su-25 aircraft designed for destruction of battlefield targets. The Su-25 was the nation's first mass-produced jet attack aircraft. It has several versions. It is currently a key asset of the Russian Federation combat aviation. In 1969, the designing player started development of 4th generation fighter, and in 1977, the prototype Su-27 fighter made its first flight. In the following years, the Su-27 platform was used to produce the Su-27UB, Su-30, Su-32, and Su-33. The aircraft building experience gained by the design various team over many decades made it possible to produce a family of aerobatic airplanes, the Su-26, Su-29 and Su-31. With this machine, the national aerobatic team of USSR and Russian Federation have won a total of 330 medals, 156 gold medals at the World and European Championships. Sukhoi civil aircraft is currently engaged in development of a family of regional airplanes Sukhoi Superjet 100.
Thank you, Vladimir. And now we are moving on, and Rudikov Sergei and Martin Pavel will begin the third part about Sukhoi Superjet 100, and Zakhar Artyom will continue.
Sukhoi Superjet 100 is a new aircraft family allowing its passengers to experience the mainline level of comfort. The fuselage cross-sections increases the ILO width up to 20.08, offering optimal ILO height combined with 5-abreast seat configuration. The height of the ceiling is about 83.46, while each seat is 18.31 wide. The four-breast seat configuration results in a true business class, providing every passenger with the equal level of comfort. Key technologies. The leading-edge technologies, being the core ingredient of Sukhoi Superjet 100, penetrates every stage, from design and develop to final assembly, delivering a modern, economically efficient, and globally marketable aircraft. SSJ-100 is easy and safe to pilot. The cockpit design features have a passive side stick and active engine controls. The human-centered design concept perfectly arranges the control levels and on-board equipment. SSJ-100 can be landed by only one pilot. Dark and quiet cockpit offers precise, convenient, and reliable piloting of Sukhoi Superjet 100. Thank you.
Okay, super economy. The Sukhoi Superjet 100 aerodynamic configuration is specifically optimized for high cruise speed. That's why speed increase does not lead to a dramatic increase of fuel consumption. When compared with its rivals bound to fly in economic mode, Sukhoi Superjet 100 has higher cruise speed. With enhanced takeoff and landing performance, along with all-weather operation, wide range and passenger payload capabilities, make Sukhoi Superjet 100 an efficient route development. This offers airline freedom in route and schedule planning. Super economics results from crew training, cost reduction, when operating different types of the Sukhoi Superjet 100 aircraft as a single group. Furthermore, this advantage stems to easy to reach maintenance zones. 20% reduction in the number of modular engine components and 10% cutback in fuel consumption.
One of the key features of the Superjet 100 is that it actually provides 10% decrease of the operating costs, which is due to weight compaction, low fuel consumption, and low maintenance costs. Well, the main part in this advantage is actually paid by the reduce of fuel consumption. And this is provided by some key features of this aircraft, such as, for example, third generation airfoil wing design, and also great part of this is played by perfectly balanced loss of aircraft control programmed in autopilot. But the greatest part is definitely played by its engines, because SAM 146 engines, which are produced especially for these aircrafts, actually provide a 10% decrease of fuel consumption per seat compared to competitors. Well, another important feature of this aircraft is that Superjet 100 is actually super environmental friendly, because noise and other emissions from this aircraft is reduced. Also, this aircraft surpasses all
Thank you. Finally, we want to say that each of us highly enjoyed the excursion to Sukhoi, and we know for sure that this great company has promising future. We hope that this is interesting to you too, because it suggests a brilliant career as well as a great success in life. Thank you for your attention and good luck.
Well, from what we saw at the hangar, I think Aeroflot uses Sukhoi Superjet 100, and Armavia tried to use them, but they couldn't afford the service costs. So those two planes are right now sitting in the hangar itself. And well, what else? Well, I think there were transfer.
Couple of them.
A couple of them in the hangar. And well, there are many contracts for the Sukhoi Superjet stock to be fulfilled in the next few years. So I think more companies will start to use them in the nearest future.
Could you please show the previous slide? Do you have any idea what is it? What is this one? What is it?
Was that on snow?
Yes.
What is it?
It's about the ice formation test. It is
From ice?
Yeah, I think it's a good detector. We were told about it, but we weren't sure this exact part.
Is it for ice and it should be all over the wind, but this is sitting near the root of the wind?
Well, we weren't sure this exact part, so I kind of don't know. I just know that the ice formation test, the ice formation itself was monitored by some kind of mechanism. I think it did that.
So this picture for flight test configuration?
Well, this is the first flight. The
first one,
yeah. This is the first plane because I think it is the only plane that's been delivered. Well, about the design actually, I think this delivery doesn't look very good.
Thank you.
Can I? We made this presentation about Sukhoi and Superjet, and you are through, and I have another question. We and you say everything about advantages of this plane. Has it any history?
I did not find them, so...
Well, actually, I know what the advantage. It's about the servicing of the plane. Because right now, I think it can be serviced only in Russia and in Yugoslav. And if there are to be any foreign companies to buy this plane, they would have to fly it for servicing here, and the cost of the service itself is enormously high, and which is why Armavia couldn't afford it when they went bankrupt. So, if there will be more service centers around the world which can service the Superjet 100, it will be this disadvantage will be over. But right now it is there, and it is. I think that's why foreign companies which specialize in mid-range flights are not so enthusiastic about buying the Superjet 100 because they are not so big and they cannot afford the service costs.
But the service is provided in France too.
Already?
And all the instructors and constructors of the plane say that they had made this plane only for zero, and they shouldn't do anything different hard to support this plane. They shouldn't do anything in Zhukovsky to support the plane. They shouldn't go there. It was the roads of the construction.
Well, I read different things. They were to the construction, but maybe it's kind of outdated because the plane needs to be serviced every some years.
Okay, thank you. Some other questions? Okay, then thank you very much.